Hi guys, so I was going to talk to you today about hypothesis testing and kind of a little bit of an overview of hypothesis testing. We're going to focus on section 8.1 in this video, and then I'll do a separate video for 8.2 and 8.3. So on your Moodle course, there is a document. This is under chapters 7 and 8 handouts. Okay, chapter 7 and 8 handouts. Down here below where lab number 9 is, you have one that says hypothesis testing instructions. So I want you to use this when you're talking about hypothesis testing because it kind of simplifies what's in the textbook. The textbook goes through a couple different methods and different ways to do it, and really you don't need all of that. You just need to focus on kind of one method. And the method that we're going to be using is called the p-value method. Okay. So the first thing that we have to be able to do is we have to take whatever claim is given in the problem and we have to write down the claim and the opposite of the claim in symbolic form. Okay, in symbolic form. So we're going to do an example here. So it says in this one, the mean pulse rate of adult males is equal to 68.8 beats per minute. Okay, so the claim is about the mean. So since the claim is about the mean, we're going to use mu. Okay, and it's claiming that it's equal to 68.8. So the claim is that it is equal to 68.8. So if this had said less than 68.8, we would have picked less than. If it had said greater than, we would have picked greater than, right? Or greater than or equal to, or whatever it says. So we write down the claim, which is what it asks for here, but we're also going to write down the opposite of the claim. So let me write it over here. The claim is that it equaled 68.8, and then the opposite, well, what would be the opposite of equals? It would be not equals. So we use this symbol for not equal to 68.8. Now that homework problem didn't ask for it, but we're going to write it down here because it's part of our process. So that's step 1, writing down the claim and writing down the opposite of the claim. Step 2 here, we're going to set up our null hypothesis and our alternative hypothesis. Okay, this is H0, this is H1. You'll sometimes see this called HA, that's another option. It says, remember that H0 always uses equality. Always, 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 always. So H0, in this case, is going to be the same statement, but with an equals. Okay, the mean equals 68.8. The null hypothesis always uses equals. Always, 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 always. Never changes. The alternative hypothesis is going to either be the claim or the opposite claim, one of these, whichever one does not have equality. So like this one has an equal, so it can't be this one. So it's going to end up being the opposite. So it's the mean does not equal 68.8. So your alternative hypothesis is always going to be either the claim or the opposite claim, whichever one does not have an equal sign. So it's either going to be a less than, a greater than, or a not equal to. Those are your only 3 options. So we'll pull up that homework problem. So again, our null hypothesis always uses equals. Oops. And the alternative hypothesis is going to be either the claim or the opposite claim. In this case, it's the opposite claim, 68.8. Good. Now, let's redo this one. So this one is a claim about the standard deviation of the pulse rates, and it says that the claim is that it's less than 12. So in this case, it's the standard deviation is less than 12. You're literally just writing what the claim says, but in symbols. So now let's think about over here. Let me get rid of all of this a second. Okay, so the claim is that the standard deviation is less than 12. Right? Yeah. So the opposite of less than would be greater than or equal to. Okay, the total opposite, greater than or equal to 12. So our null hypothesis always uses equals every time, no matter what, it uses equals. The alternative hypothesis is either going to be the claim or the opposite claim, whichever one does not have the equals. Well, so this one, the opposite claim has an or equal to right there. So our alternative can't be the opposite claim because it has that or equal to. So it must be the original claim. So in this case, the alternative is that the standard deviation is less than 12. So here it's the standard deviation equals 12. The null hypothesis is always equals. And the alternative is that it is less than 12. So in this case, the alternative matched the claim. In the other problem, the alternative matched the opposite of the claim. It just depends on the problem. Okay? All right, so that's writing your null and alternative hypothesis. After you write your hypotheses, you'll be testing them using the data that the problem gives you and using your calculator. But this doesn't come in until section 8.2 and section 8.3. So I'm going to deal with this in another video. Okay? This part you won't need for section 8.1. Then, what's going to happen is after you do the calculator test is going to give you what's called a p-value. The calculator is going to give you a p-value. And you use this p-value to form a conclusion. So forming a conclusion is also in 8.1. 8.1 basically does the beginning of the problem, where we write the hypotheses, and it does the end of the problem, where we write the conclusion, and it kind of skips the calculator part in the middle. So the way this is going to work is they're going to give us a significance level. Okay, in this case, we're talking about it like it's 0.05, but it might be 0.01, it could be 0.10, right? They're going to give us the significance level in the problem. The default, kind of the most common, is 0.05. So unless they tell us otherwise, we kind of assume it's 0.05. If your p-value is less than or equal to the significance level, if your p-value from your calculator is less than or equal to your significance level, you will reject the null hypothesis. If your p-value from your calculator is greater than your significance level, you fail to reject the null hypothesis. So what the book says is, if p is low, the null must go. They use that to kind of help you remember what you're doing. If p is low, the null must go, meaning we reject the null hypothesis. After you decide whether you reject or you fail to reject, you can write a final conclusion using this chart. When I teach this in the classroom, I give students this chart on the test. I give students this chart on the final exam. This is part of things I allow students to have. So you should write this down. You should have it in your notes. You can print it off. You need this. This is something that you need to have. So this is based on whether or not your original claim did not include equality or it did include equality. and whether or not you reject H0 or you fail to reject H0. Okay, those are kind of there's 4 options. So does not include equality and you reject H0, does not include equality and you fail to reject H0, does include equality and you reject, and does include equality and you fail to reject. And depending on which of the 4 options you have kind of your statement over here for how to word the conclusion. So let's look at one more example. Okay, so it says, for this one, assume a significance level of 0.05 and use the given information. So their claim is that less than 58% of adults would erase all their personal information online if they could. So we said that would mean that your claim here is that P is less than 0.58. So if your claim is that P is less than 0.58, less than does not include equality. Less than does not have an or equal to, it's just a less than. So at this point we're on the does not include equality options. Okay. And then it says that you run the hypothesis test in your calculator and you get a p-value of 0.0176. So this is what would come out of the calculator when we get to that part. 0.0176 is less than the significance level. It's less than the significance level. So because it is less than, we are going to reject H0. Because the p-value is less than or equal to alpha. If it is less than alpha, we reject H0. It says, without using technical terms, state the final conclusion. That's where this chart comes in. So we just had a claim that did not include equality, and we rejected H0. So we are using this statement here. Did not include equality and we rejected H0. So our conclusion is that there is sufficient evidence to support the claim that, what was the claim? Less than 50% of adults, 58% of adults would erase their information if they could. So let's see. There is sufficient evidence to support the claim that the percentage of adults that would erase all their information online if they could is less than 58%. We're just matching up kind of the start of the problem here, the start of the statement. We are matching this up with the correct statement from our chart that matches our scenario. Our claim did not include equality. We rejected H0. Okay, sorry, my dog's drinking water. I bet that's really loud. Okay. You need this chart to word the final conclusions. You need this, okay? In section 8.1, they're going to just give you the p-values when you need it. But in section 8.2 and 8.3, you're going to use these tests in your calculator to calculate the p-values. Okay, so right now they're just going to give it to you. So 8.1, you're focusing on writing the claim, writing the opposite of the claim, writing the null and alternative hypothesis, and then you're going to focus on writing your conclusions, okay? You don't do any actual calculating until sections 8.2 and 8.3, so I'll make another video for that. I know I went through that really fast. I'm trying to cover a lot of information with a 15-minute time limit, so it's a struggle. But I'll make another video here in a minute.